So let me speak about the turbocharger. So there are two types of turbochargers. One is a fixed geometry turbine, and the next one is that if you know, I'll give you just 10 seconds. Pause the video, go comment and come back. Good. So whoever has given a right answer, so I appreciate them. So let me go ahead. So one is a fixed geometry turbine. The another one is a variable geometry turbine. So let me go ahead and see what are those. So here's the fixed geometry turbine. So what happens here is, so this is the turbocharger. This is the exhaust side which spins the turbo and goes out. And this is the inlet side. So when this spins, this also spins. So that's how this works. And here the exhaust gases goes out, right? So for example, now imagine this is the turbocharger. So this is how it is constructed. So now what I am going to do is I want to run this. So I am going to blow this side. See, when I give the exhaust gases, this also rotates, right? So this takes the fresh air and send to the engine. So that's how this works. And in the fixed geometry turbine, example, I have exhaust duct in a bigger diameter. I'm trying to run the turbo. It's not happening. What am I going to do with this? With the same diameter, if I give much more air, anyway, I can't give that. An engine can give so much more exhaust, so then it runs. But at lesser exhaust, it doesn't run faster enough. So that is a fixed geometric turbine. So what we have done is, I'm going to reduce the nozzle. Now we can make out it's running. That is a variable geometric. So fixed geometric has a bigger diameter, lesser gas is running, but the turbine cannot run efficiently. When the gases are more, where the higher RPM, when the exhaust gases are more, it runs the turbine, that is fine. But at a lower RPM, what to do? Okay, example, you are washing your car, right? Washing your car or bike. You have that pipe, the water pipe. Open the tap fully. So whatever from the nozzle, this is the pressure, right? So I'm not able to wash the car. So when I want to pressurize it, what will I do? I'm going to close this nozzle of the duct or the pipe to half or the 3/4 so that your pressure is much more better. So when the pressure is much more better, the car is being cleaned better. So that the same how we are going to vary the nozzle opening inside the turbocharger. How? There is one small motor here. So that actually activates these vanes. So these are called the variable geometry turbine or variable nozzle vane turbocharger. So these are the variable nozzle vanes. So these nozzles can be adjusted, right? So that's how the vanes. So you close the vanes, the nozzles are narrowed down so that the less air have been pushed much more faster so that the turbine runs at a lower RPM itself. So imagine, for example, it is like this. If it is a fixed geometry turbine, the engine RPM is somewhere around 1200, 1300. What happens? This fixed geometry turbine will run somewhere around at a lower speed. But when you are accelerating more or opening the throttle, your car runs at a higher speeds, right? At those speeds of the engine, the turbocharger will run somewhere in 1.5 to 2 lakh RPM also or more than that. So then you get into performance. Here what happens in variable geometry is at a lower RPM, the turbo has to be having much more better running. So when the vanes are closed, right, the RPM, the speeds are much more better at a lower RPM itself. When you are running it 900, 1000, 1200 RPM, these vanes are redirecting it to the edges of this turbine so that the turbine runs at a lower RPM. So that lesser RPM the turbo has to run. So that's the reason this variable nozzle turbocharger is being designed. So there will be one motor here. So this motor will be actuating or activating these vanes, that is opening, closing, depending on the engine's RPM. So variable geometry turbines fab table or fab statement. Here it is. So variable geometry turbine is a feature. Advantages: turbo action starts from lower engine RPM. So benefits: driving pleasure at all times, city driving or highway driving. So at all times you will be having very good performance. So improved torque at low engine RPM. So better acceleration. Then you get reduces fuel consumption. So lesser fuel bills. Obviously, when you have the good fuel efficiency, you will be filling at lesser stations. And better burning of the fuel. So lesser emissions. So this is done. So next, let me move forward. So we have seen turbocharger, supercharger. Then let's see E-turbo. What is E-turbo or the electric turbocharger? So this is the electric turbocharger. In the regular turbocharger, what we used to have, The exhaust gas is used to spin the turbo and then goes out. But here there is a compressor here, and the electric motor is mounted to the compressor so that this runs the turbocharger. But this electric turbocharger will work as in like assisting the main turbocharger. I have come across in Audi Q7, it has an electric turbocharger also with tandem working with the regular turbocharger. It's something like this. There will be one bypass duct like this. When performance is required, that time this bypass duct will be closed. Like that, this all will be controlled by the ECM, and this electric turbocharger will be activated so that that extra air taking it from the main turbocharger and sending it to the engine again. This works assisting the main turbocharger also.